Mapei Design Fix Anchor tutorial. This is the interface used to present Mapei Design Fix, and the first thing to point out is that on the top right we can set the language of the program. For example, by selecting English, the graphic interface immediately updates to the language selected. There are various options available. Starting from the top left, you can open an existing project or directly open the last project saved. Then there is an option to update the program to the most recent version. At the bottom we find the possibility to launch the design program, view the Mapei website and a link to a web page dedicated to chemical anchor products. The central part is undoubtedly the most important. Here we find the module used to design anchors and the module used to design construction joints, that is, post-installed rebar for construction joints. Anchor Design Module. Now we will take a more detailed look at the Anchor Design Module. We will have a brief overview of the options in the various menus contained in the program. We will start from the first one on the left. Start Anchor Design. The first thing we notice is the possibility to select the reference standard used to carry out the design. Here we can choose from the standards currently in force, that is, Eurocode 2 Part 4, or the old standard, TR029. Another important option is the possibility to set the unit of measure, choosing between the imperial system, commonly used in English-speaking countries, and the SI system. Other intuitive options are the possibility to save the project on the computer, edit project data, which allows the user to add more information such as the name of the design engineer rather than the design company and other information. It is also possible to start a new project and view further information about the program itself, including the guide, Fix Help. This guide is accessible by going into the Start Anchor Design module and clicking on the Fix Help icon. Clicking on the icon, the graphic interface of the program is displayed with a description of the various options. To avoid spending too much time, we will not go into detail of all the options at this point, because we will look at them in more detail later on the program interface. The most interesting option is undoubtedly the Module Anchor Design, which allows us to access the design standards adopted and the algorithms used by the program to carry out the design. So, by clicking on Verifications and using those of tensile stresses as an example, a description pops up of all the records the program has analyzed, with a detailed explanation of which and how each one was considered. The user can also analyze in more detail the calculations actually carried out. For example, by opening the section regarding tension loads, the different failure modes will be identified. And if we go on to open a subsection, for example the one regarding concrete cone failure, we will find all the formulas, equations and calculation criteria the program adopts to carry out the various verifications, highlighting the various examples that could be encountered so that the design engineer can verify how the program carries out the calculation. Product Filter. The second menu we will analyze is the Products filter. On this page, there is the possibility to filter the products shown in the left-hand part of the window. The filter limits choice according to a series of options, such as type of anchoring product, assembly method, and type of material, which means the type of steel the rods you want to anchor are made from. For example, by limiting the choice to hot dip galvanized only, we see that only those that meet this criterion are shown. In this case, galvanized rods are not contemplated. Other filters are for the type of certification required, that is, if we only want to consider certified or non-certified anchors, the cross-linking or hardening rate of the product, and the type of rod, if we are using rebar or threaded rods. Lastly, the user can define the diameter and anchoring depth to be used. For example, we can see that in this case for Mapefix EP100, we have a series of diameters, both certified and non-certified. We also see that, by modifying this option, we limit the choice of products that have active certification, The choice of possible diameters, therefore, will be limited because those without certification will be automatically excluded. Calculation. If we move on to the next screen, we find Calculation menu, where it is possible to modify the geometry of the anchor. That is, to open an interface that allows the user to modify the geometry or also insert values in the graphic interface directly, but we will show such a design example later. Another interesting menu is Anchor Depth, which defines the anchor length, which may be calculated automatically by the program or inserted manually by the user. For particular requirements, it is possible to modify the usage rate of the anchor to reduce the ratio between applied load and resistant load. Anchor base material. Moving on to the next screen, here we can define all the characteristics of the concrete substrate in which the anchor is embedded. In this case too, the user can modify the presence of edges using the dedicated Edit Edges table, or by entering the values directly on the 3D image. And we can see that it is also possible to define whether there are any edges or not. In the concrete section, it is possible to specify the type of concrete by selecting whether it is cracked or not cracked. And lastly, the concrete class. The classes that may be selected are those shown in the ETA certification of the actual anchor. A series of characteristics may also be defined regarding the presence of reinforcement in the substrate. For example, you can choose between normal reinforcement rather than denser reinforcement. Worth pointing out here is how the program always gives a brief explanation of the choices available. For example, the description connected to the reinforcement menu specifies the meaning of normal reinforcement, and similarly for coefficient PSI-RE, which is a coefficient related to failure caused by splitting. In this case too, the program provides an explanation that allows the user to understand the characteristics and differences between the various choices available, such as the meaning of without reinforcement of supplementary edges, straight reinforcement of edges, and reinforcement with presence of clamps. So basically every menu has its own description. The final option in the central part contains a splitting section, which enables the user to specify whether certain types of reinforcement are present or not. On the right-hand side, meanwhile, we can define the type of perforation, hole conditions, and cleaning method. And lastly, you can define the in-service temperature contemplated for the specific anchor. All these choices will obviously have an impact on both the result of the calculation and on the list of products to choose from. Anchor layout. We come to the anchor layout module, which is certainly one of the most important to be taken into consideration, because it is the one that enables the geometry of the anchor to be defined. For example, in the attachment section, we find the options required if we want to create anchors consisting of steel plates and threaded rods, specifying also their layout. These include rectangular, circular, and rhomboidal. Amongst the other options available, we also find rebar, without the use of steel plates, and the special case in which we want to create an anchor for a single steel element. It is also possible to choose the rotation of the plate in order to align its length along the calculation direction specified. The user can specify the steel type used for both the vertical steel element and for the base plate, with the option to also define the thickness. In the hole pattern section, obviously it is also possible to modify the type of holes present, which means you can choose between classic round holes or slotted holes in one or more elements. The user can also modify the number of holes in the plate and concrete substrate. It is also possible to define the type of steel profile joined to the steel plate you want to consider. Then, once the type has been selected, by inserting HD type profile, for example, it is possible to define the height from a list of options present in the program. Another important option is Fill Annular Gap, which enables the user to consider the holes in the plate as being filled with the same resin used for the anchor. which means the gap present between the vertical steel rod and the hole in the steel plate can be nullified. Loads. Continuing on our analysis of the options available in the program, we now move on to the Loads option. As the name implies, in this window, rather than the intensity of the loads applied to the anchor, it is possible to define the type of load. For example, the user can modify whether design loads rather than characteristic loads should be considered. This will obviously affect the value to be inserted in the design module. Then, it is also possible to define this alpha SUS coefficient, which is a coefficient related to suspended loads, which was recently introduced following the latest revision of the standard. As you can see, the program has a brief description available of what this parameter represents and the relative standards references. In the Installation Conditions section, the user can modify the way in which the anchor is fixed to the layer of substrate. The options we have are with no bending, which means the anchor plate is in direct contact with the substrate. The user can then modify this option by considering, for example, the presence of a layer of leveling mortar under the anchor plate, or a standoff fixing, which means the steel plate is overhanging with respect to the substrate, or another type of standoff assembly in which there is the presence of a bolt with threaded nut, acting as a spacer between the plate and substrate. And lastly, it is possible for the user to define the type of load. That is, they can define a seismic type load by choosing between seismic level class C1 and class C2. In this case too, we would like to point out that the definition of class C1 and class C2 is contained in a specific ETA standard and relates basically to historic data regarding seismic activity for a given site. View. The last section of the program regards View. We won't go into detail for each single section, but with this screen we can modify the settings for the graphics of the program, which means the user can activate or deactivate each single output on view in real time in the 3D image.